Hello, and welcome to this tutorial on the time value of money, and specifically using the time value of money keys or the TVM keys on your financial calculator. So here is your calculator. If you have the BA Plus Texas Instrument, it will look like this. These are the TVM keys that we will be referring to. And they have very specific meanings, and they're actually special registries for storing variables. So like we use the store 0, store 1, these are additional registries where you can store variables, but are used specifically for doing time value of money problems. And this is what they mean. N is the number of periods. IY/Y is the yield to maturity. PV represents present value. Payment represents periodic payment, so something made every period, and then FV represents the final period, final payment in the last period. Now, before we get started, we should just do a check to make sure that your TVM payment settings are correct. Now, the default settings should be fine, but just in case they've been changed, you want to do the following. You want to verify that your default settings are set to one payment per year. So to do that, you would hit second IY. You should see displayed P/Y equals 1. If you see something different, change it to 1. Once it's 1, you can hit second CPT to quit out of that setting. Then in addition, you want to verify that the compounding period per year is 1. So do a similar thing here, second IY, but then hit the up arrow, and you should see CY equals to 1. If it's something different, change it to 1. And then finally, we want to verify that the payments are all being treated as coming at the end of the period rather than the beginning of the period. And again, this is the default setting. To verify that, hit second payment. You should see N displayed, and then hit second CPT to quit. With this one, there will usually, well, for the TIBA2 Plus, there will be an indicator that would tell you that it was beginning B that you would see in the display. So that helps protect you from having that on inadvertently. So these are important to have set because all that we do that follows, you'll get incorrect results if these are set differently than the ones indicated here on this page. Okay, so having done that, we can now go on to do some problems. Now, the first thing to put in front of you is the standard bond pricing formula, and this is really the basis for these TVM keys. So represented algebraically, it's the present value is equal to the final payment. So the future value, remember, represents the final payment divided by 1 plus the yield to the end. So this is discounting that. We could have equally made this times 1 plus y to the negative n. So you can see that in either form. So that's discounting the final payment at some yield. And we're adding to that the sum of the payments also discounted at the yield, but for the shorter periods of time. And then graphically, this shows what the payments are. So the PV is at time 0, and then essentially you can think of it as a coupon or a bond or some level payment, the same every year, including the last year, and then an additional payment on the last year. So this is the standard bond pricing scheme where you have a bullet payment at the end and coupon payments every period. And these could represent every year, they could represent every 6 months or any other period. So important to remember, particularly since we've set a number of payments per year to 1, that these are interpreted as periods. So the formula is above. You'll notice there are 5 variables. So the 5 that we saw in the preceding slide: PV, FV, Y, N, and payment. And the way it works is if you have input 4 of the variables, you then can compute the 5th. So for example, if you have input N, the number of periods, the yield, the payment, and the final payment, if those are known and you put them in, you can calculate what the PV. So that's essentially solving this equation. And if you, on the other hand, knew PV as well as N payment and FV, but you didn't know Y, that's here, then you could solve for that. And that's very important because it's actually not possible to algebraically rearrange this equation and solve for Y. So the calculator is doing an iterative calculation to come up with the Y that will make this equation correct or true. One final point that often trips people up when they first start using this functionality on their calculator is to remember that the signs of the PV need to be the opposite of the signs of the future value and the payment. And the way you can think of that is this is an outflow, maybe something you're paying in order to receive these inflows. So that's the logic behind the opposite sign convention. So it will work if you have all of these be positive and this negative, or if these are all positive, then this will come out negative, will need to be negative. So just be careful about that point. Okay, so let's look at our first problem. We're going to calculate the price of a bond using the PV key. So we know the maturity, 10 years. We know the yield, 7%. We know the coupon payment. We'll say it's $10.5 per year, or we could think of it as 10.5%. And then face value $100 or 100%. On these, make sure they're measured on the same scale. So if you're doing it in dollars, that's fine. This could be the dollars, and this could be the dollars. Or if you're doing it in percent and you put in 10.5%, remember you need to put 100% in here, so you put 100. All right, so what do we do? Well, first, good practice is to clear the TVM memory. So you can do that by hitting second V key. That will clear all of the TVM memory slots, so they go to 0. And then you can input them in this manner. So you'd hit 10, the N key, and then you should see displayed N equals 10. Hit 7 and the IY key, you should see displayed IY equals 7. Now here we're going to change the sign. So 10.5, we hit the plus or minus to change to negative, and then hit payment. And so if that's done correctly, you'll see payment equals negative 10.5. And then finally 100 plus minus to make it negative, future value, and you'll see this. Then to get the PV, you can't just hit the PV. On some calculators you can do that, but on the TIBA2 Plus, you need to hit the CPT key and then the PV key, and you will get a result that will display PV. And if you've set it to floating point, you should see this result with these digits displayed. If you had it actually on still on 2 decimal points, so if the precision was set to 2, the memory would still have this. It would just display a rounded number. So that's important to keep in mind as well. So that gives you the price of the bond. If we're doing this to the nearest cent, we would round it to 124.58. And then finally, to note that, again, that as we said, that this has to be negative, that will give you a result as positive. If you were to put these in as positive, the result would come out negative. So that could be fine. You would just interpret it appropriately as the price, as a positive price. Okay, so let's look at doing a problem where we're solving for yield to maturity. So this is really the same procedure, but instead of putting in the yield, we're going to put in the price. So let's say the price is 125, and the maturity is 10, the coupon's 10.5, and the face value is 100. And so clear memory, we input each of these again. And the thing that'll be different, of course, is PV equals 125. And then when we won't put in anything for the IY key, we'll compute that. So we'll do that last. After you've put in all the inputs, you then hit compute I/Y, and you will get this result here, which, if we're rounding to 2 decimal places, is 6.95. Now notice it is returning this as a percent. Okay, so it's not returning 0.0694, so it's already converting it to a percent for you. So that's important to recognize. And then finally, if you make a mistake and you put all of these in as positive, which is an easy thing to do. Put 125 and then forget to change the sign of this to negative, you will get an error 5 key. So if you ever see the error 5 key result on your display, when you go to calculate, you'll know that's what you did, and you can go back and make sure that they're the opposite signs. All right, so let's look at one more. Here, we're going to use the calculator to compute the payment on an annuity with the following parameters. Now, annuity is a structure where there are equal periodic payments, for example, annually, or they could be monthly or quarterly, but we'll assume they're annual in this case, and there's no final bullet. So it's like the standard bond cash flow, but without the final payment. And here we're going to assume that the price is PV. The future value is zero by definition because it's an annuity, so that will be zero. And then we've got maturity of 10 years and yield of 7%. What we're trying to come up with is if we were to say invest $500 in this annuity, what payment per year, if the yield were 7%, should we get? And this is quite easy to do on your calculator. So after we clear, we put in 10 for the number of periods, 7 for the yield. We put in 500. Now we might make it negative here if we're paying it for the price of the annuity. Remember to put 0 as future value if that was left as 100. And that's why it's important to clear that you might have left 100 in there, and that would have given you an error. So that should be 0, and then you hit compute payment. And the compute payment is going to give you this result here, which if we were rounding to cents, it would say, all right, you should expect to receive $71.19 per year for 10 years in return for a payment of $500 if the appropriate yield were 7%. Okay, so let's summarize here. So the financial calculators, for example, the TIBA2 Plus, are designed to easily do these basic time value of money calculations. The 5 key variables are the number of periods, N, the yield to maturity, the present value, the periodic payments, and the final payments, and their specific keys on the calculator. Different calculators may have slightly different names for the keys, but you'll see some variation on this. But these are the exact names for the TI-BA2 Plus. And then we saw that given basically 4 of the variables, assuming they're consistent, the calculator will solve for the 5th variable. So we could use that to calculate the price of the bond, the yield of a bond, the payment for an annuity. So to see more about the TVM and about the TI-BA2 Plus functionality generally, I would refer you to the user's guide. You probably have a printed copy of it as well with your calculator, but there's also an online version with lots of detail. So that's a good resource. So that's it, and thank you for listening.